In this video, I'll talk about firewall rules. Firewall rules control network traffic flow. Traffic is either allowed or denied on a per network interface level. A firewall appliance, whether it's a server, physical or virtual, with multiple network interfaces, or a router, is going to have more than one interface. So we then can control the rules and tie them to a specific interface. So the traffic can be coming into an interface or it could be leaving an interface. And when we configure firewall rules, depending on the product that we're using, we'll have to specify that distinction. Firewalls can be network based, so we have to think about the placement of the firewall appliance so that it can see all the traffic that it potentially would allow or deny. And of course, every host on the network, be it a server, a laptop, or a smartphone, and so on, should have a host based firewall configured in addition to our network based firewall solutions. With firewall rules, we should have a deny all traffic by default rule. Then we would add rules to allow traffic only as we need them. So for instance, if we need to allow HTTP traffic, then we could add a rule to allow that. But if any packets come in through the firewall that don't match that HTTP rule, then our deny all by default would kick in. Rules are processed using a top-down approach. So the first matching rule, so if there's some kind of criteria that matches what's in a packet, it gets executed and no further rules get checked. So the last rule then in your list of rules should be a deny all. Some products will actually display this because it's there automatically, whereas others won't display it even though it is effective. Here on the screen we see some examples of inbound rules, where we get to decide in the leftmost column whether we are allowing or denying traffic. Notice our last rule at the bottom denies all protocols from all sources going to all destinations for all interfaces. However, our first rule allows TCP traffic from a specific source subnet of 172.16 with a 16-bit subnet mask. And it allows that type of traffic to a specific host, in this case 172.16.056 for port 22, which is used for SSH remote administration. And that's allowed on our firewall device through interface Ethernet 0. Now we can also see the second example allows TCP traffic from all sources to all destinations as long as the port number is 443, so HTTPS secured web traffic. And that again is tied to interface ETH0. Our third rule allows UDP traffic from any source to a specific destination going to port 53. Now if you recall, DNS client queries are sent to UDP port 53 on the DNS server. So this is allowing DNS server queries from clients to reach host 172.16.0.100. We should also consider whether or not we're going to log firewall actions, whether packets are accepted or dropped because they don't meet conditions that were specified in rules. If we're going to turn on logging, then we probably want to turn on log forwarding so that our log information is stored on another host as well. So if the firewall appliance itself gets compromised, well, the logs can't be trusted, of course. We've got a copy elsewhere on a trusted host. In our logs, we also have to decide whether or not we want to see IP addresses for the data that we're logging through the firewall, or whether we want to do reverse DNS name lookups to see the actual DNS names of the hosts connecting through the firewall. Now, in many cases, you probably don't want to use reverse DNS name lookups while the log information is being generated because it's a little too resource intensive and takes time to do the reverse lookups. So instead, another option is to have IP addresses of hosts logged in the firewall logs, and then if you need to, when you're analyzing the logs later, you can do the reverse DNS name lookups to get the names of the hosts if that's helpful. And that could be a manual or an automated process. In this video, we talked about firewall rules.